1-5A. So we're going to spend a few days on logs, and we're going to start with doing our properties of logs. So like I said, I'm not going to write the properties of logs down because you know them. And if you don't know them, they're on that the back side of that worksheet I just gave you. All right, so here we go. We're going to have 3 parts today, A, B, and C. Letter A. We're going to start by evaluating. We're going to evaluate some logs. Okay, and maybe some of you are really good at these. You're pretty quick at them, and some of you struggle a little bit. It's not a race. Here we go, number 1. So we're trying to find the exponent. So let's evaluate. Letter A. Let's do log of 100. Now let's recall when you do not have a base, when the base is not given, it's base 10. So what we're really doing here is we're doing 10 to the what equals 100. Yeah, and the answer is 2, right? 10 squared is 100. Find the exponent that goes on the base of 10 to give us 100. All right, so let's do a harder one. Let's do log 1/49 of base 7. Ooh, okay, some of you are going to be fast at these, some not so fast. So we say 7 to the what power, 7's our base, raised to what exponent, gives me 1/49. Fractions are usually going to be the negative exponents that drop them down. We know that 7 squared is 49, so to drop this down to 1/49, the answer is -2. You remember these, huh? Were you good at them?
No.
Okay. 30%, really good. All right, log base 3 of -27. 3 to the what is -27?
Oh,
We're trying. Guess what?
1/3.
No solution.
Oh.
You can't take the log of a negative number.
Don't try and trick us like that.
3, I can do whatever I want, really. 3 to the what is -27? You kept trying things. That was great. You were like 1/3. 3 cubed is 27. Try -3. None of those were working. Because nothing, 3 to something gives me -27. Nothing is going to make it negative. All right. Let's do this one. Letter D. Let's go with log base 4 of 2 plus log base 4 of 8. Now, you can do this one of 2 ways. You can separate it, keep it separated, and solve them each individually, which those are kind of tough. 4 to the what is 2? Do you know that? It's 1/2. It's a tough one. So the square root of 4 is 2. But why don't you combine it? It'll make it into a much better problem. Whenever you have a plus in between logs with the same base, you can rewrite this as log base 4 of what? 2 times 8.
Close.
2 plus 10. It's so fun that we make fun of people when they get stuff wrong, because I never try to do that in my classes, but in here it's funny. It's like, and he's cool with it. He's like, oh, whatever. Like when this guy gets a bad grade on a test or quiz. This guy. All right. So the question is 4 to the what is 16? 2. 2 again. 2. Okay. Should we do some harder ones? Yeah. How about if you were doing this one without a calculator? Log base 2 of 16 cubed. Log base 2 of 16 cubed, all right? And you weren't allowed to use your calculator. What you should do is use the property that says you can bring that exponent down to the front. Because remember when you have exponents, 2 exponents, you multiply. So you get 3 times the log base 2 of 16. Well, that's a little tricky too. What is log base 2 of 16? 2 times 2 times 2 times 2. That would be 4, right? 2 to the 4th is 16. So you're going 2 to the what is 16. So 3 times 4, your answer is 12. That's hard. Those are hard.
Oh, okay. The answer they multiply by 3.
Yeah, so the 3 moves to the front, becomes times. You figure out what log base 2 of 16 is. It's 4, and 3 times 4 is 12. What about if it was log base 2 of 16 cubed? Okay. You have to use correct order of operations. You have to do inside of the parentheses first. This is different than the last one. You can't bring the 3 down. Yeah, whatever answer you get in here, you cube it. So that would be what? What's the answer to the inside? We just did that. Log base 2 of 16 is 4, and 4 cubed is 64. Different problem. Those parentheses made a huge difference there. Letter G. How about, oh, this one's cute. Log base 4 of log base 5 of 25. Okay, when you get something complicated like this, you're like, how am I going to take the log of a log? That's just crazy. Start by simplifying what you can. Go to the inside your parentheses, and evaluate that. What is log base 5 of 25? It's 2. So change this to the log base 4 of 2. And then ask yourself, 4 to the what is 2? 1/2. Square root. Really good, huh? Let's do one more of these. I love these. They're just fun. Yeah, you heard me. 1/2. Log base 2 of 8 plus 8 plus 16. Okay, this looks complicated too. You're like, am I going to take the log base 2 of 8 and then plus or times the log base 2 of 8 and 16? No, take what's in the parentheses, simplify the problem first, and then evaluate the log. So 8 plus 16 is 32. Ooh, I heard it. Log base 2 of 32 is 5. 2 to the 5th is 32. You guys are good, real good. Okay, let's try this one now. Number 2. Suppose that I'm given that the log of 9 is rounded to 2 decimal places. It's 0.95. Okay? And then I'm also told that the log of 2 is equal to 0.30 rounded to 2 decimal places. And then they say to evaluate. Evaluate this. Log of 9/2. Okay? And you're not allowed to use a calculator still. You're only using what they gave you. Yes, it is. So use your log properties. This is log of 9 minus the log of 2. And guess what? They gave you what those are, right? So log of 9 we know is 0.95, and the log of 2 is 0.30, and then we subtract and we get 0.65. Exactly. Nice, huh? So good. That one's easy. Let's do a harder one. How about the log of 8? Well, they didn't give me log of 8. They gave me log of 9 and log 2. We're thinking exponents. How can we get this 8 to be in something with 2 in it? With exponents. We can rewrite this as log of what? 2 to the 3rd? Are you thinking that? Okay. Log 2 to the 3rd, this is the same thing, right? 2 to the 3rd is 8. Bring the 3 down to the front, because that's a log property. It's actually my favorite property. And then you go 3 times the log of 2, and the log of 2 is what we have. So you want to get everything to log 2s or 9s, log 9 or log 2. And we have 0.30, so our answer is 0.90. How is log of 8 equal to the log of, 0.95, okay. Whew. Thought that was a bad problem. Is that good? Yeah, it's pretty good. Okay, let's move on to part B. 3. Rewrite as a single log. We want to get this all into a single log. So it's all going to be spread out. We want to bring it all back into one single log. Number 3. All right, suppose you have log base 3 of 20 minus log base 3 of 4. Oh, this one's going to bother you. Plus 1. And I want that whole thing, including the 1, all into one log. You're like, what? That's not even a log to begin with. Okay, so here we go. You notice what we're doing. It's log base 3. So I need 1 to be log base 3. How do we write 1 as with the log of base 3? Do you know what that is? Yeah, someone said it. Log base 3 of 3. No? Usually don't change that. Like if someone says, oh, how old's your kid? Oh, he's log base 3 of 3. No, he's 1. You know, it's kind of silly to like go that way. But if we're writing it all as one single log, you have to kind of think about, okay, I got to take 1 and change it into a log base 3. And now I can go ahead and do all the stuff. Here we go. So we have log base 3. I've got 20 minus 4. So that's going to be divided by 4. Plus is going to be times 3. Okay, so this log base 3, that log base 3, and that log base 3. This is minus, so it's divide. And when I multiply something, do I multiply on the bottom or do I multiply up top? Up top. Okay, if this was parentheses, then the whole thing would be divided. But it's not. And so let's go ahead and change this. This is what?
Wait, what do you mean if this was parentheses?
Ooh, okay. So if this problem was minus that, then they would both go on the bottom. But it's not. So then I get log base 3 of 15. Just write it as one single log. You don't have to evaluate it. That's it. Just log base 3 of 15.
Wait, so why does like 1 equal log base 3?
Because 3 to the what equals 3?
Oh, okay.
Yeah. So 1 is always log base A of A. Log base A of A is always 1. So no matter what it is, log 4, log 5, log 6, it would be log base 6 of 6 is 1. All right, number 4. Let's do another one. Log base 2 of x minus 3 times the log of y squared. Now, as you notice, these are a little trickier than what we've done. And we did them in Algebra 2. They were kind of easy. We're getting used to properties. In Ham-Around, we kind of upped it a little bit in Chapter 3. And then here, you know, they expect you to know all the properties, all the rules, all the stuff. Oh, sorry, there's a little 2 right here. They're both log base 2. I'm not trying to confuse you. All right, so we go log base 2. We've got this x. Now it's minus 3. So what we're going to do is we're going to move that 3 up to here, and we're going to divide. Minus for log properties is division, and this is going to be y squared cubed, which is y to the, no? Y squared, and then I'm moving the 3 to the top of it, so y to the 6th. You multiply your exponents. Did I lose you on some of that? Some of you got lost? This 3 right here moves to the top as an exponent on top of the y squared. So it's y squared cubed, which is y to the 6th. You try one. Number 5. 5 times the log of 2x minus the log of y minus 5 log x. Okay, you try this one. This one's a little complicated. Try and get into one log, and then make sure you simplify if you can. I think this one you can.
We got interesting Parks and Rec stories.
Oh, okay.
Because me,
Yeah?
Jacob, and Kyle.
You guys all like that show?
No, we
Oh.
work in the parks.
Oh, you worked there. Oh, okay, got it. All right, minus, so we're going to put that on the bottom. And then this one too, x to the 5th. All right, let's fix this now. We got to fix it. So maybe you got it to there. That's great. And you get log of 2 to the 5th is what? 32. And then x to the 5th and x to the 5th will reduce, leaving you with that final answer. Yay! Okay,
Wait.
yeah?
All the x5.
So the 5 comes down.
No, yeah, so this 5 went to here, so they were both x's.
Just
Wait,
the
can you
5
do
down.
the numerator again?
X5 over x5 cancels out, right?
Yes. Yep. So this one is x to the 5th, bless you.
Yeah, I got that.
Okay. And then up top I have a 2 to the 5th and an x to the 5th, and what I did was I reduced those because they were the same.
But
And
you
then
still put 2 to the 5th?
2 to the 5th is 32. Yep. You got to distribute it to both. Okay, last part. Now we're going to expand and simplify. We're going the other way. Expand and simplify if possible. Okay. So number 6. Let's do log base 5 of x over 5. So now we have a log of some stuff, and we need to expand it into as many logs as we see. So for this one, I have just 2 parts. I have x and I have 5. Yeah.
Are we expanding or expanding?
X. Whoopsie woo woos. Expand.
Nice, got it, dude.
I make so many mistakes on Mondays. It's crazy. All right. Log base 5 of x. And this is division, so it's minus log base 5 of 5, which we can simplify, right? What is log base 5 of 5? We just talked about that. It's 1. He's like Lenny. So cute. Well, you know why Lenny's 1. Well, what's the base of natural log? It's E. Oh, no. He's just a little baby. All right, number 7. Let's do this one now. Let's do...
Wait, why is your Lenny on the side?
Oh, Lenny's 1. He's 1. Because he has base E.
Doesn't matter.
It's just like this one, log base 5 of 5. This is log base E of E.
Yeah.
Still 1.
Could we give you an answer with log base 5x minus Lenny?
No. That's way more complicated. All right, try this one. Log of 8x to the 4th over W. Okay. The biggest mistake that people will make on this one, especially in Algebra 2, even in HAM, is that they don't see the top as 2 separate things, but it is. There's 3. You're going to have 3 logs here. I know. People do that. They'll keep the 8 and the x to the 4th together. And this one has 3 parts, so you need to break it up into 3 logs. Okay? So this is log of 8 plus 4 log x. And you move it to the front. Minus log W. And there's no simplifying in this one. Log of 8. Can't really, it's a decimal. Yeah.
You could do something, we're just trying to make that as much
Yeah, expand. Uh-huh. Yep, start with simple, expanding it. Let's do one more. Last one, number 8. Here we go. Yeah.
8b 2 to the 3rd.
Well, this is base 10.
So you can put 3,
Oh.
Yeah, you could do 2 to the 3rd and bring down the 3 and do 3 log 2. Yeah, that would be fine. That's a little bit extra. You don't need to do all that. You could. He's breaking it down to the smallest log possible. That's okay. All right, let's do this last one. Log of 100 square root x. Log of 100 square root x. Let's break that down and simplify if possible. So this would be log of 100 plus log of the square root of x. Let's simplify this. We got to change this. So that's 2, right? 10 to the what is 100 is 2. Plus, and this one, square root of x is x to the what? 1/2. So bring the 1/2 down. 1/2 log x. Lots of rules to remember, huh? And with these, it's kind of hard because, like, how far do we go? Like, when do we stop, you know? Like, you kept going there, and that was fine, and we stopped, and it was fine, too. Do you remember